This is problem number 8 from section 310. In this problem it says a balloon is rising vertically above a level straight road at a constant rate of 5 feet per second. So this y of t, or this dy over dt here, they're saying is 5 feet per second. Just when the balloon is 114 feet above the ground, a bicycle moving at a constant rate of 18 feet per second passes under it. So they're saying the bike passes under this balloon right here, this spot, and that this height here is 114 feet. So 114 feet at time equals 0. That's something that's important right there. Time equals 0. And it's moving at a constant rate of 18 feet per second. So we're going to say that this is dx over dt is equal to 18 feet per second. How fast is the distance s of t between the bicycle and balloon increasing 6 seconds later? So we're going to say time equals 6 seconds here. 6 seconds. And then we're looking for ds over dt. Now this is a triangle. It's similar to the other problems that we've done. Basically what we're going to try and do here is we're going to use the Pythagorean theorem to solve this. Now they don't give us any x and y values after 6 seconds, but we know the constant rates that they're moving, so we can actually figure out what this triangle is at the time 6 seconds later. So let's go ahead and figure that out. So if I draw the triangle, I'm going to simply take 114 feet, which is the distance that the balloon was above the ground when the bicyclist passed underneath it. 114 feet, and then I'm going to add, so we're going to say height after 6 seconds. And then we're just going to say that that's going to equal 114 feet plus 5 feet per second times 6 seconds. Which you can see when you do that, 114 plus, that'll be 30, that'll be 144 feet. So the balloon at 6 seconds, or 6 seconds later, is at 144 feet. So this is 144 feet here. The bicyclist is traveling 18 feet per second, so we can get this distance, x, to be 18 feet per second times 6. So we're going to just say that this distance here is going to be 18 feet per second times 6 seconds, which when we multiply those, we get 60 and 48. We're going to end up with 128 feet. So moving pretty quick there. Oop, I did that wrong. 18 times 6. This is actually 108. Bad mental math there. 108 feet. All right. So now that we know this is 108 feet, this is 144 feet, we can use the Pythagorean theorem and basically say I'm going to use s for this side, and we're going to say that s squared equals, this will be x side, x squared plus y squared. And then I'm going to do the derivative with respect to time for this whole thing. And when you do this, remember none of these variables are t variables, so you're going to be using implicit differentiation the whole time. So we're going to say that 2s ds over dt equals 2x dx over dt plus 2y dy over dt. Now, keep in mind, we know that dy over dt, we know the dx over dt, we know this one, this one. We're trying to find this one. We know x and y because we just found those. The only thing we don't know is s. Well, we can use the Pythagorean theorem to find that. So we're just going to say that s squared equals 144 squared plus 108 squared. So S equals root, I'm going to put that in the calculator, 144, 20,736 plus 108 plus 108, no, times 108. That's 11,664. Let's add those together. So plus 20,736. And now let's square root it. So when we square root that, we get 180. So this is 180. Well, guess what? It's 180 feet. We have everything we need. We have S, X, Y, dy dt, dx dt. All we need to find is ds over dt. Before I start, I'll divide the 2s across, and then let's plug it all in. So ds over dt equals 2x dx over dt plus 2y dy over dt all over 2s, which is going to equal, now technically we can divide this by 2 and this by 2 all at the same time, so we're going to say that this is really x dx over dt plus y dy over dt all over s. Let's plug them in. X we know to be 108. Dx over dt is 18 feet per second. We've got plus y, which is 144 feet, times dy over dt, which is 5 feet per second. And that's all over s, which is 180. When we plug all that in the calculator, this is what spits out. So we'll start with the 180 times, or 108 times 18. This is 1,944. This is feet squared per second. Plus 144 times 5, 720 feet squared per second, over 180 feet. Add all those up, so plus 1944, and divide it by 180, you get 14.8, and when you divide the feet out, you end up with feet per second. So that is the change in S that's occurring. So this distance between the balloon and this bicycle, this distance, the straight line distance, is increasing by 14.8 feet per second. That's pretty quick.